right, so let's get started. I hope everyone did well in the midterm. Regardless of how you did, we gotta just keep on pushing forward. If you didn't do too well, you should be able to bring it back up on future exams. And if you did well, then let's just try and keep a good thing going. So, without further ado, let's get right into lesson 7. So, to get into lesson 7, we have to do a little bit of review. So, first off, just review what a normal distribution is. It's a subset of a symmetrical distribution. It's bell-shaped. It has a mean of 0 and a standard deviation of 1. Another name for it is a z-distribution. And so 100% of all observations are going to fall underneath the curve. Also a z-score, it's the distance between an individual score and the mean and standard deviation. All right, so next up we have the central limit theorem. Basically what it says is if the sample size is sufficiently large, then the sampling distribution will be approximately normally distributed. Easy enough. All right, so when we're using the normal distribution, we're going to want to use it for hypothesis testing. Basically, it's going to be the exact same thing as the hypothesis testing. You're going to want to write out a hypothesis, calculate the test statistic, determine the p-value of that, and you're going to want to make a decision and then state in a real-world conclusion. It's the exact same process of regular hypothesis testing. So the normal distribution method, if the sampling distribution is approximately normal, a normal distribution is constructed with a mean equal to the hypothesized parameter, which is another way of saying the null hypothesis. And the standard deviation is going to be equal to the standard error, and you got to use this to find the p-value. You guys have already done this, to find p-value. It's just a little bit of a different twist on it. So the standard normal distribution method. So if you want to use the z-score, it's the test statistic. When using the z-distribution, the test statistic is a standardized value that is the boundary of the p-value. So basically, it's just z-score equals x minus x bar, or the standard deviation. It's the exact same thing as you guys have done before. And then when you're conducting a hypothesis test, the sampling distribution will be centered on the null parameter, and the standard deviation is known as the standard error. So another way of thinking about it is the test statistic is going to equal the sample statistic minus the null parameter divided by the standard error. This is all stuff that you guys have probably seen before, just kind of like written a different way. So confidence intervals. When using the standard normal distribution method, it's the 95% confidence interval is equal to sample statistic plus or minus 2 times the standard error. The general form of a confidence interval is sample statistic plus or minus the z multiplier times standard error. And then the z multiplier can be found on the z distribution. It's basically kind of like the p-value kind of. So to find the z-score, it's that separates. Sorry, if it's for a 95% confidence interval and you find the z-score that separates the middle 95% from the outer 5%, it's pretty much the p-value. Binomial probabilities. If you guys haven't really noticed, this is a very, very fast lesson. There's not too much new stuff. It's basically just taking old stuff and kind of flipping it a different way. So what a binomial random variable, it's a discrete random variable that kind of counts how often a particular event occurs in a fixed number of tries. So the one I like to think of is, the number of heads you get after flipping a coin 5 times. All conditions must be met for it to be, officially be a binomial random variable. So it has to have a fixed sample size, that is the 5 times. The probability of success is the same on each trial. So basically there's nothing that would make it lean one way or the other. Every single time that an event occurs, there's still going to be the same chance that one thing is going to happen compared to the next. There's no changing of anything, and the trials have been independent. The trials are independent of one another. So basically, you're not just building on it. It's completely random. And just a little bit more for calculations. So the mean, the way you calculate that is just going to be n times p, and the standard deviation is just going to be square root of n times p multiplied by 1 minus p. So yeah, going back to the example with the previous one that I used with flipping heads on a coin 5 times. So with that, n is going to equal 5 and p is going to equal 0.5. So to find the mean, it's just 5 times 0.5 to get 2.5. And to find the standard error, it's just the square root of 5 times 0.5 times 1 minus 0.5, or just times 0.5 again, and you get 1.118. So the way to conclude this is the mean number of heads when 5 coins are flipped is 2.5 with a standard deviation of 1.18. And with that, we're already into review. So just select all the statements that are true about standard normal distribution. I'll give you guys a little bit of time, and I'll give you a hint. There's more than one correct answer on here, so you have to pick more than one. So I'll just give you guys a little bit of time. All right, close. So the correct answer is that it's symmetrical, has the mean of 0, standard deviation of 1. It will not be skewed because then it cannot be a normal distribution. And we don't know if it's binomial or not. That really just comes down to, what we're running on it, because there can be plenty of standard normal distributions that are not binomial. So. All right, so review 2, just compute the test statistic given that xm minus xf equals 2.445 with a standard error of 1.55. Yeah, so the answer is going to be A. It's just x minus x bar, which they present to you in this way, which can be a little confusing to some people, but they can pretty much present it however they want. And then divide by the standard error, which is just going to be 2.445 divided by 1.55 to get 1.58. The null is not always going to be 0. The null can be like whatever value they want it to be. If it's going to be, if you're going to use a normal standard distribution to find, if you're using it with it being centered around the null hypothesis, then it should be 0. But it can change. It'll. Most times it's going to be 0, but in cases like this, you don't know what it is or what it isn't, because there could always be the chance that it's not 0. It should, for a normal distribution, it should be centered at 0, but there are always, cases where it's not. So I think that kind of answers your question. Sorry. All right, so number 3, which of the following is a binomial random variable? All right, so correct answer here, C. So the reason why it is C is just because it constitutes all 3 rules where you have a set sample size of 20, you have the same probability that something is going to be chosen, and each trial is independent of each other. So the issue is that for D, you don't really have a set sample size, and for A, you also kind of don't have a sample size, and there's also the issue that it's not each trial is not independent of each other, and then for B, you also don't have a set sample size because it's just how many times before you get the first head, which could be however long. So if you just remember the rules for it to be a binomial random variable, you should be fine. All right, so review number 4, according to a newspaper, 40% of all college students attend college sporting events. If we took a random sample of about 200 college students, how many would we expect to attend college sporting events? I'll give you guys like a minute for these problems are pretty easy. You just have to take the sample size of 200, multiply it by the percent right here, which you get 200 times 0.4, which equals 80. So good job, guys. And this is actually going to be the last one. So what is the standard deviation for a distribution of a binomial around a variable with n equals 100 and p equals 0.3? I'll give you guys a little bit for this. All right, I'm gonna go over this one. So it's not that hard. The answer is C. So it's the square root of 100 times so it's just this n sample size times p of 0.3 times 1 minus 0.3, and you get 4.58. So with that, that brings us to the end. Just, you know, the deal by now. So thanks for coming by. Hope this helped, and I'll be sure to answer any questions you have.